Good afternoon, boys and girls. Today we're going to be dividing fractions. It is module 4. Good afternoon, boys and girls. Today we're going to be dividing fractions. It will be module 4.2 and 4.3. And so if you could put that at the top, I forgot to write it at the top of my paper. But if you would do that, and then also go back to your table of contents and write dividing fractions, module 4.2, 4.3, and this will be on page 16 and 17 of your spiral notebook. You can turn the tape back on when you after you finish doing that. Okay, so our first lesson is going to start with a definition. It's a definition of a reciprocal. A reciprocal is two numbers whose product is 1. And product, remember when you see the word product, you think multiplication. So we have an example, A over B and B over A. They are reciprocals because when you multiply A times B, you get AB. And then when you multiply B times A, you get the same two letters, which is equal to 1. So it's easier to show you with numbers. So let me show you with numbers. So the reciprocal of 2 ninths is 9 halves. And when we multiply that together, we have 18 over 18, which is 1. The reciprocal of 1/8 is 8 over 1. So when you multiply those together, you have 8 over 8, which is 1. And the reciprocal of 5, well, first we need to turn 5 into a fraction, so it's 5 over 1. Any whole number as a fraction is over the number 1. Multiplied by its reciprocal 1/5 equals 5 over 5, which equals 1. So those are examples of reciprocals. You're basically just flipping the fraction upside down. Okay, our second square, by the way, you're going to need 6 squares. I'm hoping that you, I forgot to say that in the beginning one. You'll need 6 squares. So divide 5/9 divided by 2/3 and write the quotient in simplest form. So the first fraction never changes. The second one, we're going to use the reciprocal, which is 3 halves, and we're going to multiply. Okay, so then we have 15 divided by 18. However, that is not simplest form. So what number can go into both of those? 3. So we're going to do 5 goes into 15 5 times and 18 6 times. And so that is our final answer because it's in simplest form. Okay, let me show you a little trick called cross reducing. So we have 5/9 multiplied by 3 halves. Same problem. So, is there a factor that goes into both 5 and 2? No, but there is a factor that goes into both 3 and 9, and it is 3. So 3 goes into 3 once, goes into 9 3 times. Now you multiply across. So 5 times 1 is 5, 3 times 2 is 6, and guess what? It's already in simplest form. Saves you so much headache when you can do it this way. Okay, for box 3, we are going to be dividing mixed numbers, which is very similar to improper fractions or just fractions, but we need to change these into improper fractions first. So 7.5 becomes 30. Whoops, let me get my pencil. Becomes 35. No, yes, 35. Over 2 divided by 5 times 1 is 1 plus 2 is 7 7/5. And then let's rewrite that as a multiplication problem. So we have 35 halves because the front number never changes. Oops. Times, we're going to use a reciprocal, 5/7. Okay, 5 and 2 do not have a common factor, but 7 and 35 do. They have 7. So when I multiply, 5 times 5 is 25. 2 times 1 is 2. So let's turn that into a mixed number. 2 goes into 25. 12 times with 1 left over. Bottom number never changes. 12 and a half. Okay, that's it for box 3. Okay, for box 4 we're going to do a word problem. So the word problem reads, the area of a rectangular sandbox is 56 2/3 square feet. The length of the shoebox is 8.5 feet. What is the width? Okay, so we're going to do a 3-step problem. So remember that area equals length times width. Okay, so we have the area, which is 56 2/3, and we have the length, which is 8.5 feet, times W. Okay, so in order to find out what W is, we need to divide 56 2/3 by 8.5. So let's do that. So step 1, well, 56 2/3 divided by 8.5. Okay, so that's step 1, deciding what we need to do. All right, so step 2, we're going to change these mixed numbers into improper fractions. So 56 2/3 becomes 170 over 3 divided by 17 over 2. Okay, step 3 is to do the multiplication problem involved. So we have 170 over 3 times 2 over 17, which is a reciprocal of 17 over 2. Okay, can we cross reduce? Well, no, we can't. We can't do the 2 and 3, but we sure can do the 17 and the 170. Thank heavens. So that would be 1, and this would be 10. So then we're going to multiply that out. We have 20 over 3, and we turn that into a mixed number. We get 6 2/3. Okay, that's box 4. Okay, for box 5, we're going to do 3 examples. Let's do 9 over 10 divided by 2/5. If you want, you can either just walk through it with me, or you can try them on your own and then play the video and see if you have the correct answer. Okay, so for the first one, 9/10 over 2/5, the first thing I need to do is use the reciprocal. 9/10 multiplied by 5 over 2. Can I cross reduce? Nope. So, wait. Yes, we can. Sorry. I'm sleeping. Got to keep your eye on me all the time. 5 goes into 10 twice. Okay, so we have 9 over 4. And when I change that into a mixed number, it becomes 2 1/4. Okay, let's try the next one. 8 1/3 divided by 2 1/2. So the first thing we'll do is turn it into an improper fraction. So we have 25 thirds multiplied, divided by, let's do divided by first. 5 halves. Now now we'll flip them. 25 thirds multiplied by 2/5. Okay, we can cross reduce here. This is 1, this is 5, which gives us 10 over 3, which when we make that a mixed number, that becomes 3 1/3. Okay, our last one will be 9/10 divided by 3/5. So since they're already fractions, we'll just rewrite it as a multiplication problem using the reciprocal. Can we cross reduce? Yes. 5 goes into 10 and 15, or excuse 10 and 5. And 3 actually goes into 3 and 9. So when we multiply that out, we have 3 over 2. And when we make that a mixed number, it becomes 1 and 1/2. So let me circle these answers so they kind of stand out better. Okay, so there we have box 5. All right, our last box will be a word problem sample. So the word problem reads, Sheila has 10.5 pounds of potato salad. Yum, that's my favorite, by the way. She wants to divide it into containers, each of which holds 1¼ pounds. How many containers does she need? Okay, so let's write out the problem first. She has 10.5 pounds of potato salad. So let's write that out, 10.5 pounds. She wants to divide it into containers. So we know we're going to be dividing into containers, each of which holds 1¼ pounds. So we are going to be dividing by 1 1/4. How many containers will she need? Okay, so let's turn these into improper fractions, because remember, you can never, ever, ever divide mixed numbers. 10 times 2 is 20, plus 1 is 21 over 2. Then we have, that's 5 over 4. Then let's turn that into a multiplication problem. We have 21/2 multiplied by 4/5, which is a reciprocal. Can we cross reduce? Yes. There's a 1. There's a 2. 21 times 2 is 42. 5 times 1 is 5. And when I turn that into a mixed number, I have 8 2/5. So she needs 8 2/5 containers. Well, guess what? Do they sell 2/5 of a container? No. So how many containers would she need? She would need 9. Needs 9. Hopefully I can write containers on these with my stylus. Not bad. I'm getting better. Okay? Alrighty. We'll see you tomorrow in class for some more examples. Bye, guys.